we're looking at proving and applying similar triangles. And to prove triangles are similar, we need to be able to list any pairs of corresponding equal angles or pairs of sides in a given ratio. You may remember to give reasons at each step, and we need to write a similarity statement. For example, something like triangle ABC is similar to triangle DEF, or triangle ABC is approximate to triangle DEF. And then with those, we need to make sure that we have our similarity test abbreviated rule. So side, 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 angle, side, angle, 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 or RHS. So in example A, we need to be able to identify what information do we have here that can help us solve it. And automatically we can see that we have parallel lines. We also have vertically opposite angles. We can even use the Z rule. So we're going to start off with angle BAC. So angle BAC sits there. And we're going to say it's equal to angle DEC. It sits there because of that. So I'm going to write angle BAC is equal to angle DEC because of the Z rule, alternate angles, and therefore line DE is parallel with AB. Remember, two vertical lines like that tells the reader that that means parallel. So that's why we have alternate angles, to be able to prove that those two angles are equal to each other. The next set of angles are also alternate angles, and we can say that angles ABC is equal to angles EDC because of the Z rule. Really important that you include your rule for the proof. That's your reasoning. And then vertically opposite angles, as said earlier, we have angle ACB is equal to angle ECD. And that rule is our vertically opposite rule. So then our statement, therefore, triangle ABC is similar to triangle EDC because a similarity test. So in example 1b, we have a large triangle and then a smaller triangle BCD, triangle AEC, and then CBD in the corner there. And they're saying prove that those two are similar. So I'm going to redraw the triangles. So the first triangle I'm going to draw is AEC. And then I'll redraw triangle CBD. Not perfectly to ratio, but that's all right. So we assign our letters and our values that we know. So we know that length of AEC here is 12. We know the length of AC is 18. We also know that the length of DC is 6. The length of CB is 4. So we know now, looking at these two similar triangles, that we're going to have to do something to work out the scale factor. They've given us sides, and there's also the possibility that, well, not the possibility, but there's the certainty that we're going to have to use an angle as well. And the reason I say that is because it's smarter for us to be able to use this angle C here, because it's common. Both triangles are going to have the same value, angle C, because it's shared. So that's going to be my first proof that I put down. Angle ACE is equal to angle DCE because it's a common angle or a shared angle. There's our first one. And then we have our other line. So we know that line AC corresponds to line DC. So we've got a scale factor problem here. So we're going to put AC divided by DC, which is equal to 18 over 6. So we know we have a scale factor of 3. So then we go and check it with EC and BC. So EC divided by BC is going to be 12 over 4. 4 goes into 12 3 times. So then that is equal to AC over DC is going to be 3 as well. So therefore, triangle ACE is similar to triangle DCB because of SAS, side angle side. Example 2 here is a little different worded question. Chris's shadow is 1.2 meters long when a vertical stick has a shadow of 0.8 meters long. Missing a key piece of information here. Chris's shadow is 1.2 meters long when a 1 meter vertical stick has a shadow of 0.8 meters long. Give a reason why the two shadows make similar triangles and determine Chris's height. So let's draw a diagram to represent this. So let's say Chris, his shadow casts this way, and that is 1.2 meters long. We then have a stick, 1 meter, and that stick shadow goes 0.8 meters long. Now those triangles can be represented as such. And so we need to find the scale factor relationship. Now the sun is going to be shining from the same direction. The way in which this question is set up suggests that all angles are the same. So for A, give a reason why two triangles make similar triangles. Why the two shadows make similar triangles. Well, it's going to be, we know that the lengths are different, but all angles are the same. And what are those angles? Well, we don't really need to know. We just know that they will be equal. We know that there's two right angles in each one, or one right angle in each triangle, but we don't actually need to know what the other angles are. To solve B, Chris's height, we need to use the scale factor. So the scale factor is going to be equal to 1.2. We're going to look at the lengths of the shadows over 1.8. 1.2 over 1.8 gives you 1.5. So then Chris's height is going to be equal to the height of the stick, which is 1 meter, times the scale factor, which is 1.5 meters, which gives you 1.5 meters. So Chris is 1.5 meters tall. And that's your answer. This one's a little tricky, a little hard to get your head around. All angles are the same, but essentially because they make similar triangles, and the question is telling you they make similar triangles, and you just need to say why they make similar triangles. The shadows are falling in the same direction. The height of the stick is a scale factor of Chris's height. The length of the shadows are scale factors of each other. Therefore, there's a relationship with all angles in the triangle. For part B, we looked at the scale factor. We took our length of the shadow of Chris, the length of the shadow of the stick, divide them into each other, realize that there's a relationship of 1.5. Chris's height is then equal to the height of the stick times by the scale factor, which is the same because it's only 1 meter. So 1 times 1.5, 1.5 meters. Chris is 1.5 meters tall.